about homeostasis and feedback mechanisms.
Ever wonder why we inhale or exhale? Or how our wound is treated or repaired after gore or injury?
Or how our body reacts to certain situations and release chemicals in order to maintain balance?
If you are curious how our body works that way, just keep watching till the end of the video. Our body needs to sustain its balance in order to live accordingly. And when we eat sugary foods, we need to tone down a bit. So what's the meaning of all this?
The tendency to maintain a stable, relatively constant internal environment is called homeostasis. The body maintains homeostasis for many factors in addition to temperature.
Homeostasis is maintained at many levels, not just for the whole body as it is for the temperature.
For instance, the stomach maintains a pH that's different from that of surrounding organs. Maintaining homeostasis at each level is key to maintaining the body's overall function.
Biological systems, like those of your body, are constantly being pushed away from their balance point.
Like, when you exercise, your muscles increase heat production, nudging your body temperature upward. Similarly, when you drink a glass of fruit juice, your blood glucose goes up. Homeostasis depends on the ability of your body to detect and oppose these changes.
Maintenance of homeostasis usually involves negative feedback loops. These loops act to oppose the stimulus or cue that triggers them.
Menstruation is a normal vaginal bleeding that occurs as part of a woman's monthly cycle. Every month, your body prepares for pregnancy. If no pregnancy occurs, the uterus or womb sheds its lining. The menstrual blood is partly blood and partly tissue from inside the uterus. It passes out of the body through the vagina.
Behind the scenes are a series of hormonal controls that fine-tune the body's internal workings to make menstruation.
So what's the positive and negative feedbacks of menstruation?
Each month before puberty, the hormone-producing pituitary gland in the brain starts releasing two substances in the blood, follicle-stimulating hormone and luteinizing hormone. The egg cells grow and estrogen levels peak, inhibiting the production of follicle-stimulating hormone and telling the pituitary to pump out more luteinizing hormone.
Meanwhile, the now empty follicle begins to release progesterone, another hormone that tells the woman's lining to plump up the blood and the nutrients in preparation for a fertilized egg that may embed there and grow. If it doesn't embed, the body's progesterone and estrogen levels plummet. The womb stops padding out and start to degenerate. Eventually, falling away, blood and tissue leave the body, forming the period.
Soon afterwards, the ovaries begin to secrete estrogen again, and the womb lining thickens, getting ready to accommodate a fertilized egg or be shed.
Hormones continually control these activities by circulating ideal amounts delivered at just the right time.
The cycle keeps on turning, transforming each day and each week into a milestone along its course towards pregnancy or period.
During most of the menstrual cycle, estrogen and progesterone provide negative feedback to the hypothalamus and pituitary gland. This keeps their levels more or less constant. During the 12 to 14 days, however, estrogen provides positive feedback to the hypothalamus and pituitary gland. This causes a rapid rise in the production of estrogen by the ovaries and leads to ovulation.
This depends on negative feedback loops, so anything that interferes with feedback mechanism can and will be disrupt homeostasis. In the case of the human body, this will lead to disease.
Insulin decreases the concentration of glucose in the blood. After you eat a meal, your blood glucose levels rise, triggering the secretion of insulin in the pancreas. Insulin acts as a signal that triggers cells of the body to take up glucose for use as fuel.
Glucagon does the opposite. It decreases the concentration of glucose in the blood. If you haven't eaten for a while, your blood glucose levels fall, triggering the release of glucagon from another group of pancreatic cells, the alpha cells. Glucagon acts in the liver, causing glycogen to be broken down into glucose and released into the bloodstream. causing blood sugars to go to back up.
Unlike the negative feedbacks, we also have the positive feedback. It amplifies the starting signal. Positive feedback loops are usually found in the process that needs to be pushed for completion, not when the status quo needs to be maintained.
A positive feedback loop comes into play during childbirth. In childbirth, the baby's head presses on the cervix and activates neurons to the brain. The neurons send a signal that leads to release of the hormone oxytocin from the pituitary gland. Oxytocin increases uterine contractions and thus pressure on the cervix. This causes the release of even more oxytocin and produces even stronger contractions. This positive feedback loop continues until the baby is
Are
born.
biological mechanisms whereby homeostasis is maintained.
Positive feedback amplifies change, while negative feedback reduces change.
Remember this, the key difference between positive and negative feedback mechanism is their response to change.
Without feedbacks, homeostasis cannot occur. This means that an organism loses its ability to self-regulate its body. Negative feedback loops are common in homeostasis, but positive feedback loops are also important.
Wow! I really learned a lot today. Both positive and negative feedback mechanisms are equally important.
That's right, it maintains our homeostasis, so if ever you're feeling down, you'll always have someone to cheer you up.
Well, I agree. So, well, folks, this is the All Girls Club. Goodbye!
Bye!